Haven't we all thought about it? That deep-seated human desire to see what came before, or what's yet to come, to witness history with our own eyes, or to catch a glimpse of the future. It's one of the greatest dreams of humanity, and as it turns out, it's not just a dream.
So let's just get right to it. Is this all just for the movies? Is time travel just science fiction? Well, the line between fiction and fact is a lot blurrier than you might imagine. And to truly understand why, we first have to completely change the way we think about time itself.
You see, before you can start any journey, you need a map. And for most of human history, our map of the universe was missing a huge piece. We saw space and we saw time, but we saw them as two completely separate things.
For centuries, we'd lived in Isaac Newton's universe. The idea was simple. There was one giant cosmic clock, and it ticked at the exact same speed for everyone and everything everywhere. But then, a man named Albert Einstein came along and shattered that idea. He showed us that time isn't absolute, it's flexible, and most importantly, he showed us that space and time are fundamentally linked. They're woven together.
Here's a simple way to think about it. Let's say you're invited to a party. The invitation gives you 3 coordinates: 48th Street, 11th Avenue, 16th floor. Okay, you've got it. You can pinpoint that exact location in space. No problem.
So you head over there, you find the building, you go up to the 16th floor, and the room is empty. The party's over. You missed it. Why? Because you only had half the information. You knew where the party was, but you didn't know when it was. You were missing that crucial 4th coordinate, time.
And that's the revolutionary idea. You simply cannot separate space from time. They're bound together in a single 4-dimensional fabric we call spacetime. Every event that has ever happened or ever will happen, from the birth of a star to you right now, has its own unique address in spacetime. This is the new map of our reality.
So, if that's the map, can we actually travel on it? Let's start with the future. Is it possible to get a ticket to tomorrow or the next century? The answer, incredibly, is yes. We already know how.
The first way involves speed, a lot of speed. Einstein's theory tells us something truly strange. The faster you move through space, the slower you move through time. So if you were in a spaceship traveling near the speed of light, your watch would tick much, much slower than a watch back on Earth. When you came back, you might have aged only a year, but everyone you left behind could be decades older. You would have arrived in their future.
And listen, this isn't just a thought experiment. This has actually happened. The Russian cosmonaut Sergei Krikalev spent a total of 803 days orbiting the Earth at thousands of miles per hour. As a result of that immense speed, he is now approximately 0.02 seconds younger than he would be if he'd stayed on the ground. It's a tiny amount, yes, but it is real, measurable time travel.
But speed isn't the only way to do it. Einstein also discovered that gravity has a powerful effect on time. You see, he realized gravity isn't a force in the way we usually think about it. Massive objects, like our own planet, literally bend and warp the fabric of space-time around them, like a bowling ball on a trampoline.
And where space-time is warped, time itself flows at a different rate. This has been tested. Scientists took 2 incredibly precise atomic clocks and synchronized them perfectly. They left one at the base of a mountain, where gravity is just a little bit stronger, and took the other one to the very top, where gravity is a tiny bit weaker. When they brought the clocks back together just 24 hours later, the one from the mountaintop was ahead. Not by much, only about 20 billionths of a second, but it was ahead. The person who walked up that mountain literally traveled into the future of the person who stayed at the bottom. Gravity bends time, right here on Earth.
Okay, so the future seems possible. It's an open road, you just need a fast enough car. But what about the other direction? What about the past? Well, this is where our journey hits a wall, a big one. Because traveling backward seems to break the most basic rules of the universe.
There's something physicists call the arrow of time. It's the reason why things in our universe only seem to move in one direction. It's all because of a law called entropy, the rule that things always move from order to disorder. You can pour cream into coffee, but you'll never see it unmix itself. An egg can fall and break, but the pieces will never just leap back together. This one-way street of cause and effect appears to be unbreakable.
And even if you could somehow reverse that arrow, you'd run into some serious logical problems. The most famous one, of course, is the grandfather paradox. What if you went back in time and stopped your grandparents from ever reading? Well, then your parents wouldn't be born, which means you wouldn't be born. But if you were never born, who went back in time to stop them in the first place? It's a riddle that seemingly has no answer.
Now, physicists have some theories about how to get around this. The simplest one is just impossible. The universe has laws in place to prevent these paradoxes. Another idea is the multiverse, that when you travel back, you don't change your past, you actually create an entirely new parallel universe. Or maybe, just maybe, the universe is self-correcting. You can go back, but you can't change a thing, because whatever you were going to do was already a part of history.
After all of this talk about speeding through space and wrestling with paradoxes, the most profound truth about time travel might just be the one we've overlooked.
The most incredible realization is this: you don't need a machine. You are a time traveler. Right now, you, me, all of us, we are all moving through the fourth dimension. We are all journeying into the future, 1 second at a time.
And what's more, you alter your personal rate of time travel every single day. Every time you get on an airplane, that speed causes time to slow down for you, just a tiny bit. Every time you climb a mountain, or even ride an elevator up a few floors, that small change in gravity changes the speed at which you experience time. These differences are far too small for us to notice, but they are real.
See, it was never a question of if we travel in time. We all do. We are all passengers on this constant, unstoppable journey forward. The only real question left to ask is, since you're already on the journey, where is your future taking you?